All right, so what this week and what the next test is going to build on is not only how to not wear your hoodie when you're in class, but also we're going to continue to solve quadratic equations. So what would you expect to see this entire week? If we're going to solve quadratic equations, we're going to see the equal sign. And quadratic, what does quadratic mean? The variable is going to be squared, which we've already done. You did it on the test. The only thing is the only way you knew how to solve it was by factoring. We're going to delve into some other methods for solving quadratic equations. The first one is by using square root property. You could maybe argue this will be the easiest of the bunch. Tomorrow is going to be the pain in the neck. Anywho, so let me just write this out at the same time. When I say the variable, what does that imply? Yeah, that would imply that there's only going to be one. And in a quadratic equation, there could be how many different types of variables? Huh? Okay, maybe I'm wording it poorly, but see, like even if there's only x's, you could have an x that's being squared, the quadratic one, but then you could also have a linear x, which those two are not like, they can never be combined, so you have an x that's squared and an x that's not. Square root property only works when you don't have that term there. Or you can think of it as like if b is 0. If you don't have that b, if you don't have that middle term, then you can use what we do today. If not, you can't. You have to have the a term because if not, it wouldn't be quadratic. If I took this away, I'd be taking away the square, and it wouldn't be quadratic anymore. Oh, but by the way, last word on the test. If you look, I put the grades in right away, so you should have already seen this weekend what the scores were on the test. So then, like I said, as long as I'll ask tomorrow to make sure I have permission, but I don't think it'll be a problem. I'll give them back on Thursday, and then we'll go over them on. Instead of working on the homework on Thursday, we'll just work on we'll go over the test. What square root property does is it allows you to treat the quadratic equation like a linear one. Before I got here and you solve linear equations, what do? You put variables on one side of the equal sign. You put non-variables or constants on the other side. And that's what we're going to do. All terms with a variable on one side, all constants on the other side. But eventually, at some point, in order to be able to solve for the x, you're going to have to get rid of the square. So the same way that you know how to do opposite operations, like to get rid of adding, you subtract, to get rid of multiplying, you divide, how do you get rid of a square? Yes? You take a square root. Okay? Well, that's where square root property comes in. If you have an equal sign, if you are solving for an unknown, and at any point you have to take the square root. The square root was not there before. You are having to perform a square root on both sides in order to get rid of a square. What square root property tells you is that on the next line, whatever you get on the other side of the equal sign, whatever's on the other side of the x, you have to take into consideration the positive version of that radical or the negative. Basically, like this is not the best way to. This is somewhere I found online, but really the way that you see it in most places is if x squared is equal to a, and you take a square root on both sides, that means x is equal to plus or minus. And if you think about it with numbers, right, because you guys don't think too well with letters, let's think of it with numbers. What's the square root of 25? But is 5 the only number that I can multiply times itself to get 25? What's negative 5 times negative 5? Also 25. That's why square root property works. When there isn't an equal sign and you're just asked what's the square root of 25 and you say 5, what you're taking there is called the principal root. If it's an expression and there's no equal sign and you're just being asked to take a square root, yeah, you only give the principal root. But when there is an equal sign and you're solving, If you take a square root of a number, you need both the positive and negative version of that number. So that's what we'll do today. Here's an equation. How many x's do you see? Well, I only see one, and it just happens to be that that one x is being squared. Okay, so believe it or not, you could still solve this with what we're going to do later this week, and in some cases, you can even solve this with what we did last week. Like this will probably take the square root of 324. Somebody with a calculator, take the square root of 324. What'd you get? 18. It's 18. So this is a perfect one to start with. What's another name for this? Notice how we have this equal to 0 already. What do you call it when you have a negative in the middle? Huh? Yeah, I could tell that you didn't do very well on this one on the test last week, but we definitely went over it in class. What do you call it when you have a difference of two perfect squares? It is called the difference of squares. And how does the difference of squares look like in factored form? If it only had a name and you could just tell it to me in one word, conjugates, very good. Like I already know that the answer here is going to be positive and negative 18 because it just coincidentally, this could also be solved by factoring. But not everything that can be done by factoring can be done by square root property and vice versa. So let's just solve this one by square root property. What did the first step say to do on the notes I just gave you? Isaac, it's over here. What did the first step say to do on the notes I just gave you? Put the variables on one side, constants on the other. So what would be my first step in this equation? Lewis? All right, let's add 324 to both sides. Because basically all I'm trying to do is isolate. So I get x squared is equal to 324. So what's the last thing I have to get rid of in order for x to be by itself? The square. How do I get rid of a square with a square root? But anytime there is an equal sign, and you are introducing a square root into an equation that was not there before, you have to use square root property. Square root property says, okay, go ahead and get the x by itself. That's what you wanted, you got it. But on the other side, whatever it is that you get, you have to stick a plus or minus in front of it. We said the square root of 324 was 18, so that means that x could be either positive 18 or negative 18. You should be writing a solution set. I didn't take away credit from anybody on the test for not writing a solution set, but that's what it should be. How many solutions does this equation have? How many numbers make this equation true at the beginning? 2. Both positive 18 and negative 18. Yes, ma'am. Just add that number to 324. No, yeah, that's actually the big difference. One of the big differences is that for a square root property, because we're moving the constants on one side, yes, it's not going to be equal to 2. Tomorrow is going to be the same thing. Tomorrow we do completing the square. It's the same thing where you want to get rid of the constants and move it to the other side. But then on Wednesday, now we're going back to making it equal to 0 when we do quadratic formula. So yeah, that first step is important. Still plenty of examples though. Okay, this one here is not equal to 0. And even though you see two different x's, both of those x's are being squared. If, like, for instance, one of these x's was not to be squared, if I were to get rid of this square, this could not be solved by square root property. It could still be solved, but you're either going to have to use factoring, even though factoring doesn't work very often, or either of the methods that you're going to learn either tomorrow or Wednesday. So we do have a square, since they all have squares. Let's put all the variables on one side, and let's put constants on the other. We should have also hopefully learned from last week that our life is made considerably easier if the coefficient in front of the x squared remains positive. So what would be, how could I do that? How could I keep the number in front of the x squared positive, but then also move the constants to the other side? Minus x squared would be a good start. Let's It's going to move all the x squares to the left. And then what do I do after that? Lewis? And then subtract 16 to move all the constants to the other side. So I have 2x squared minus x squared is x squared. 7 minus 16 is negative 9. The only thing left to get rid of is the square. How do we get rid of a square? Square root. Uh-oh, SpaghettiOs. I have the x that I wanted. And square root property says I'm supposed to put a plus or minus. But go ahead and take the square root of negative 9 on the calculator. It does say error. Lewis, don't start telling me about imaginary numbers. In Algebra 1, we stick to a regular real number line. We do not go to the complex plane. So if any of you have been exposed to imaginary numbers, yes. Eventually in Algebra 2, you'll learn that this is plus or minus 3i, with I being an imaginary unit. But for Algebra 1, you don't have to worry about that. You would just say that this equation has no solution. Oh man, if you could only put no solution last week. Take the square root of negative 9 on the calculator. Where's your calculator, Ellie? You want to borrow one? Okay. Yeah, but that's not negative. It's not 9. That's a negative 9. It is impossible to multiply a number times itself and get a negative. What's a positive times a positive? What's a negative times a negative? That's why Adrian said that when she tried taking the square root of 9, it wasn't that her calculator was broken. It said it just gave her an error. Any questions there? Ooh. Fun. All right. How many x's do we see? And even though there isn't a square directly on top of it, this is still considered quadratic because the x is inside the parentheses. Now, as far as what to do, you're gonna have to kind of fight back your instincts on this one because you're used to all along. Hey, I see parentheses, must get rid of it, must get rid of it, must get rid of it. And it's not that this can't be solved if you get rid of the parentheses. It's just that you won't be able to solve it with square root property. Because if I get rid of this parentheses, just I'll give you a sneak preview. You'd have to do like x minus 1 times x minus 1, which would end up giving you x squared minus 2x plus 1. And the fact is, I would go from just having an x that's being squared to now having an x squared and an x. I won't be able to solve it with square root property. If I get now, yeah, those other numbers still, like I'd still have a 2 on the outside, I would still have a plus 3 and all that stuff. But the fact is that I would have both an x squared and an x. So I actually need to keep the parentheses intact and just work my way from outside in. I need to get rid of all the numbers on the outside first. And so eventually then I can get on the inside, knock out that minus 1, and then I'll be done. What would be the first number I get rid of in order to get x by itself? The plus 3. Well, I guess I wasn't around for this, but I know when you're solving for a variable, technically you're supposed to go backwards PEMDAS. If PEMDAS is how you do operations, Alex. Stat method is how you cancel. So the last operation I'm going to cancel is the one that's in the parentheses. Okay. Then the next I'm going to cancel our exponents, which will be here. These are the last ones. Okay. Then before that, I'm going to look for any division or multiplication, which is here. Meaning, what's the first one I'm going to get rid of? Any adding or subtracting. So which one is that one? The 3. I'm going to get rid of the 3. Sad, man. Let me know if you need some positive reinforcement. 2 times x minus 1 squared is equal to 18. Ellie, you saw how, look, there's a number there already. Just add or subtract, whatever like you normally would. You asked about over here, what happens if there wasn't a 0. So if there's not a 0 on the other side, there's a 21. But okay, what's 21 minus 3 is 18. And then, we're going to get rid of the 2. And since the 2 is multiplying, we divide good. So then we have x minus 1 squared is equal to 9. And then, square root, good. So we get x minus 1 is equal to plus or minus. Let me go back and write this on the board again. Sad, like Alex meant. See, when you're solving an equation and you're going to get rid of an exponent like we just did with the 2, in many cases it comes towards the end. So yeah, you get that plus minus and you're done already, and there's nothing that has to be done afterwards. But because there's still an operation left, in this case because there's a kind of a parentheses, really, like the plus minus means plus or minus. If there's nothing else to be done, you can leave it that way. But since there is still an operation to be done, what I need to do is break this up into 2 equations, kind of like I did with factoring. Remember how with factoring I would get 2 different equations and make them each equal to 0? I got to do the same thing here because there's still work to be done. So now I would get this x minus 1 and make it equal to positive 3, and I would get x minus 1 and make it equal to negative 3. Because that's what plus or minus means. If there weren't any steps left to be done, Leslie, then you can just put your head down and be happy, but if not, you should keep your head up. In the words of the famous philosopher Tupac Shakur, keep your head up. All right, since I have more than one solution, I'll write a solution set. What are my solutions? 4 and negative 2. If I get crazy and write negative 2 and 4, is that going to be wrong? No, the order doesn't matter. Those are the 2 numbers that make my equation true. If I put them in at the beginning, it makes it true. That joke was no problem, huh, Adele? I'm going to get through as many examples as I can, but tomorrow we're moving on. So. Are you trying to force yourself to smile? Yeah, it's working. No fractions. We're not going to be scared, though. We're not going to be scared. We're going to be brave. Luckily, we only see the x that's being squared. There is no x anywhere else, so we can use square root property eventually. But before we can use square root property, guys, to get rid of the square, what do we need to get rid of first? If we're trying to solve for x. Cassandra, what number do you want to get rid of first? Good. The opposite of minus 3 is plus 3. 1 over 7 x squared is equal to 7. And then good, yeah. I'm multiplying by a fraction. So you're like, well, Mr. Romero, the opposite of multiplying is dividing. Aren't you supposed to divide by 1 over 7? Yeah, but fraction and division, they don't work well together. So you should have learned already that the opposite of multiplying times a fraction is multiplying by the reciprocal. What is the reciprocal of 1 over 7? Also known as 7. So times 7 times 7 cancels out. All the children rejoice because x squared is equal to 49. The time has finally come to get rid of the square. You go to bed. Oh, that's true. How do you get rid of the square? Square root, and because I use a square root, what needs to show up? And if you blow this on the next test, it's going to be shame on you. Plus or minus what? 7, good. So solution set. Plus or minus 7. Facts. I'm just keeping it 100. Syria, what do you want to do first? What? Okay, how? Good. So we add 2. Notice how, again, we're headed towards square root property because we only see this single x. And even though you're like, yeah, but mister, that x is not being squared. It's inside of parentheses that's being squared. So it counts the same way. It's just that whatever's in the parentheses, the creamy center of the Oreo, that's going to be, that's coming out last. You don't like Oreos? What's wrong with you? That's like the greatest cookie of all time. You're nasty. Don't never talk about Oreos like that. What's wrong with you? Okay, next step. Good, take a square root. I gotta get rid of that square. I will not get into the inside of the parentheses until I cancel out that square that's guarding the parentheses. So I'm left with 3x minus 8 equals, good, plus 4 minus 4. Have I solved for the variable yet? No, I have not. So that means I'm not done, and because there's still more steps to do, I'm gonna split it. 3x minus 8 can be both positive 4 and it could be negative 4. And then you should be able to take it the rest of the way because we turn these down to linear equations. Plus 4 plus 4. 3x is equal to 12. Divide by 3. X equals 4. Plus 8 plus 8. 3x equals positive 4. Divide by 3, divide by 3. 4 cannot be divided by 3. It cannot be reduced. So we just leave it as 4 over 3. Yeah, but I went fast on the linear part. Like that's stuff you've been doing since the good old days with the math teacher. Back when math used to be fun. You were the king of the elementary school, Isaac? He ran it. Any questions there? Yes, you have a question? No? Here, why don't you guys do that one, then you solve for X. Raise your hand when you got it. Yeah. What'd you get? That sounds about right. Yeah. Oh wait, no, I think you got it backwards. What'd you get? So yeah, that one sounds better. Pretty sure that one's gonna be the right one. You got the signs wrong. Ellie, what was your first step? I like that. Ellie, what was your next step? You what? Okay, I'll be divided by 2. So x plus 2 squared is equal to 25. And then, so x plus 2 is equal to plus or minus 5. And since we're not done, there are still steps to be done. X plus 2 could be 5, or x plus 2 can be negative 5. Minus 2 minus 2. X could be minus 2 minus 2. X could be negative 7. Ellie, I'm guessing, did you add 2 instead of subtracting 2? So 3 and negative 7. It doesn't matter the order. Just put negative 7 and then 3. Fine. Tiffany, why the stink face? You understand what we're doing? Say something now. This week we only have 1 day for each. So. Nothing says turkey like working on a math packet over the break. So that's good. I just gave you a packet. Or I mean, you could do a Khan Academy might be shorter than that, but yeah, you gotta pick one or the other. Again, this assignment that I just gave you is not due this weekend. It's due the weekend after you eat turkey. It's because Adrian doesn't like you. Do this one. You already got it, Louis? Cheater. Cheater, cheater, pumpkin eater. Everybody. Once I start saying it, it's gonna catch on. Did any of the other children get it already? Syria, you got something? What'd you get, Syria? Yeah. Because it was just plus 8, cancel, x squared is equal to 64. And then once you take the square root, x can be positive or negative 8. To write a solution set. Any questions? Leslie, ¿alguna duda? No. ¿Extraña a Jocelyn? No. ¿Están fajadas? Sí. All right, do this one too. Man. I think you got it. All right, let's see. -1, -1. 2x minus 2 squared is equal to 64. Isaac, what do you want to get rid of next? Which one? There's 3 of them. Which one? Enrique, which one do you want to get rid of next? It doesn't matter. Just leave now. Who said that? Say it again. Who said that? Good. The exponent. Square root. Square root. So 2x minus 2 is equal to plus or minus 8. Don't forget the plus or minus. Has the variable been isolated? No, but since we got rid of the square, we made these linear equations, so we can take this back to the first month of school. Let's say 2x minus 2 equals 8. 2x minus 2 equals -8. Plus 2 plus 2. 2x equals 5. Sorry, equals 10. And then that gives you 5 divided by 2. Sorry, I got ahead of myself. And then plus 2, 2x is equal to -6. And then you divide by 2. 9 out of 10 m's agree. Excuse me, -3. X can be 5 or it can be -3. Some people might have you believe that you have to write the numbers from least to greatest, but you don't have to. Any questions? Ooh. Do it. Just do it. Do it, stop sucking up. Battery will get you nowhere. How fast is going to take care of this one? Oh. You actually could have a little bit right now, but you got to pick it up. So I would scratch that off. I just got lucky that one was square that you get trouble. Plus 3x squared plus 3x squared plus 6 plus 6. So whether you did it in one step or did it in 2 steps, everybody on their paper should have 4x squared equals 100 or -100 equals -4x squared, depending on what side you chose. Now, before you get too excited and get rid of the square, though, if you're going sad map, you're going backwards, you got to get rid of the multiplication next. So divide by 4. So that x squared is equal to plus or minus, is equal to 25. And then when you take the square root, that gives you plus or minus 5. My dreams of being the American Idol are done. I will never be the next anymore. Yeah, I'd be one of the people that they cut and make fun of. Tiffy, which one would you get rid of first? What number? Good. I think I'm gonna post you guys today. I did it on Friday. And they're gonna get grounded. Horror movies. And then what? Good. The way you get rid of multiplying by 1/2 is to multiply by 2, like they do in the hood. So x plus 2 squared is equal to 100.
100.
And then we do square root property, which means on the next line I got my x plus 2, but plus or minus 10. So since I'm not done solving, I gotta split it. Two separate equations, minus 2 minus 2. X is equal to 8. Minus 2 minus 2. X is equal to negative 12. So we got 8 and negative 12.
I got it.
Booyakasha.
I'm sorry.
She hated. Nice question? No? I'll do this one together. I don't need to make a noise. Oh, what's the first step?
I don't know. Divide.
So x plus 1 squared is equal to 4.
4. Stop changing the square. No. Yes.
Alpha is next step. So alphas and alphas only. What's the square root of 4? Has the variable been isolated? And that makes Lewis angry, and when Lewis gets angry, he splits it. -2 -2. Sorry, -4 -1. So x equals 1. -1 -1. Yeah, we actually got through a whole packet.
No.
I've been referred to as a songbird of my generation.